All right, Algebra 2 students, we are back in our absolute value function notebook, and we are on Tier 3, Lesson 7. Let's check that off. Here we are, Tier 3, Lesson 7, positive and negative intervals from an equation by finding the intercepts. What I wanted to do in this lesson is give you different absolute value functions and let you explore the different ways that you're going to get positive and negative intervals. So here with the first one that I'll circle in pink, let's graph that one. That one is basically the parent function transformed vertically by 1. So it's going to go up 1, and then it'll be 1, 1, there, 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 there. That's a quick little sketch. Something like that, and something like that. So as you can see here, when I draw in my x-axis, because if you recall from Unit 1 in previous lessons in this unit, as you recall from Unit 1 and from previous lessons in this unit, a positive interval is when the graph is above the x-axis, and a negative interval is when a graph is below the x-axis. So with this pink graph, the entire thing is above the x-axis. So the way you would write the positive interval is you would write that it's negative infinity to positive infinity, and there's no negative intervals. Moving on to the next function, we'll do that one in purple. We know that this is the parent function transformed down vertically by 1 unit, so it would go here at 0, -1, and then again we can sketch in this graph. We want to sketch in darker where our x-axis is, because again, positive intervals have to do when the graph is above the x-axis, and negative intervals have to do when it's below the x-axis. So here with the purple graph, we have one negative interval, and that negative interval is when it's below right here, and it's below from -1 to 1. So that's our negative interval. And then we have two positive intervals. Our positive intervals are when it's above the x-axis, so it's from negative infinity, because remember these go on forever, all the way down here to where it hits at -1. And then again, and we would write that as a union, which is this real big dark U, which in math means or, but it's an inclusive or, meaning that it could be one or the other or both, from +1 to infinity. And those are our two positive intervals on that graph. Let's go take a look at this other one, and we'll use orange on this other function. And we can tell that it has a vertical reflection and then a shift. And we know that we do the reflection first, so it's going to turn us upside down first. I'm not going to draw it. And then we would go down 1. And because we were turned upside down, we're going to be like this. These are going to be our points. And we want to sketch that in. And here, after we sketch in a darker version of our x-axis, close enough, we can see that there are no positive intervals because there's nothing above the x-axis. And we can tell that our negative interval is from negative infinity to positive infinity because the entire graph is below the x-axis. The last one we'll look at, we'll sketch in green, is this f of x. Again, we do the vertical reflection first, so we know it's going to be an upside down V, or the start of an A, however you want to look at it. And then we go up 1. So we're going to go up 1. And then we're going to put on our points, because it's just the parent function shifted up 1, and then reflected. And then again, I'm going to put in my x-axis. And I know that I have two negative intervals and one positive interval. Well, let's do the positive interval first. It's from here to here. So I know that is from -1 to 1. And then I know that my two negative intervals are here and here. So my two negative intervals are from negative infinity to -1, union 1 to infinity.